Hello everyone and welcome to this video on Schottky Diode and Schottky Transistor. So this video will be covering about a different type of diode which is named as Schottky Diode and using of this transistor, using of this diode, how you are going to make it a transistor that would be shown. And this is the series of videos in week 3 video which is a self-learning topic number class number 7. Coming to the outcome of this video, after the completion of this lecture, students will be able to explain the switching characteristics of Schottky diode and Schottky transistor. You will be having a knowledge how to what are the characteristics of your Schottky diode and Schottky transistor. You could be able to get it. Coming to the first of all, Schottky diode. So we have seen about the PN junction diode. So PN junction diode is a semiconductor diode which is used in different applications. We have seen a lot of applications for the PN junction diode. Similarly, a Schottky diode is also a semiconductor diode which is used in a variety of wave shaping, switching, and rectification applications. Okay, as it is equivalent or more or less same as junction diode. Only a small change would be there in this diode. Now we'll see what is the change of that one diode. So the change over here, and before going to the change in the construction of the diode, we'll be looking at this one. The main advantage of this diode is that, so here usually the cut-in voltage would be for PN junction diode would be 0.7 volts. But when you go for Schottky diode, it would be less when compared to the PN junction diode. It is very much less than PN junction diode. So it is less than PN junction diode. It is the major part. This one has an useful applications in rectification, signal conditioning, switching through to TTL and CMOS logic gates using main, low power and fast switching speeds. So when you go for TTL gates and CMOS gates, this is very much useful at short video. So we'll be discussing the TTL configuration using of these short videos. So what is the short diode construction and how the symbol would be represented for short videos? So this is the construction of a short diode. So when you go for looking at the geometry of this one, usually a PN junction diode will be having a P-type material and N-type material formed with N and P-type. Then in between these two, you'll be having junction. So here also, when you go for this one, you are having N-type and a junction is there. But here, this area, P is being replaced with the metal. So what happens is that when you are replacing with the metal, this junction is being used to be smaller, very small junction will be formed. It's like when you go for the application, this is the construction of a Schottky diode, and this is the circuit symbol, just like in a xenon diode, but here square type of representation would be shown. So, like this is the representation for a normal PN junction diode. So this PN junction diode, if you want an Schottky diode, what a small change would be there. This representation, this is the Schottky diode. Anode and cathode would be the similar like ones. So this above is a simplified and a symbol of Schottky diode in lightly doped N-type semiconductor, which is joined with the metal, and this is called as metal semiconductor junction. The junction between a metal and N-type is called as a metal semiconductor junction. Since there is no P-type, the first thing is that there is no P-type, only N-type is there. So therefore there is no majority carriers at all. What you will be having only the minority carriers there because P type is absent. In the construction of there is no P type semiconductor. So there would be only the minority carriers. Holes. And when you are going for reverse bias, when you are going for forward bias, it is okay, but when you are going for the reverse bias, the layout stops very quickly and changes to the blocking current flow as far as stops very quickly. It changes to the blocking current flow as far as conventional PN junction diodes. As the Schottky diodes have very rapid response to the changes in the bias and demonstrating the characteristics of a rectifying diode. Now coming to the looking at the behavior characteristics of an Schottky diode, and I'm going to be comparing with that a normal PN junction diode. So when you go for a PN junction diode, so the characteristics would be like this way. It would be starting with 0 was as you go on increasing the voltage, and once you reach it in a voltage around 6.5 over here, at this point starts conducting. You say at this point as something like 30 voltage, something like 6.5 or 6 point, sometimes you will be getting at a 7 or 6.3 if you take it. This is the current voltage. Where small changes in the input will make the output changes appropriately. So this is a PN junction diode. Fine. Similar characteristics has been shown for the Schottky metal semiconductor junction diode. Schottky metal semiconductor junction diode. Okay, once again I am repeating Schottky metal semiconductor junction diode. Every time you need to be there. So here, what would be there? You would be having with the characteristics would be similar over here, but here, if you take the breakdown voltages as it is been indicated over here, the breakdown voltages have been cut-in voltages have been taken over here as 0.7, and this will be having cut-in voltage of what 0.4. So when you take out the difference between these two, 0.7 minus 0.4, you would be having the difference of 0.3. This is the change in the say, variation in the characteristic. So this is the so immediately once we are going for shorter cutting voltages, the short videos are faster and very good. Now coming to the Schottky transistor. The Schottky transistor is um, actually, to be strictly speaking, it is a normal PN junction transistor. You can see over here, this is a normal PN junction diode transistor, PN junction transistor. Now to this PN junction transistor, we are going to implement a Schottky diode. And over here, the base and the collector, we are connecting on Schottky diode. Once you are connecting in a Schottky diode, so here the voltages are being drawn over here, and the transistor we call it as an equivalent. So when you look at the geometry or when you look at the characteristics of this one. So here what happens is that when you go for making this, when you're clamping the diode, it never allows these transistors. So whatever the transistor is there, this is the now you have clamped this one. So simple BJT transistor is there. This transistor never goes into the saturation. So every time the transistor would be in uh, active region or cut-off region. It may be not going to the transistor. So there is just an okay, when the transistor conducts normally in the active region of the characteristics, the base reverse bias and the diode is reverse bias. allowing transistor to operate in normal PNPN transistor. So when the transistor starts to saturate, the diode becomes forward bias and you will be getting a point for volt knee value. Okay, and keeping the transistor out of hard saturation as this any excess base current is being shunted through the ground. Now, by looking at this video, a Schottky diode and transistor, now you are able to explain the operation of a Schottky diode and a Schottky transistor. We will be having two. I will be doing for the one lecture level problem, or you need to explain the operation of an Schottky. So if you want to have further reading, you can refer to the textbook of Maurice Mano or R.P. Jain or some internet. Thank you for watching this video. The next video would be on TTT7, which is about the Schottky TTL. Thank you for watching this video. If you're having any doubts, you can approach.